So today we talked about 5.2, that is the definite integral. So before we talk about definite integral, let's recall what we did in 4.9, and that was antiderivatives or the indefinite integral. Okay, so the indefinite integral, the notation was this, that's called the antiderivative of f of x dx. So here our variable is x. For example, if the question was to find the antiderivative of x, so the antiderivative of x means you could say that is x to the power 1. So if we add a 1 on it, so that is x squared over 2 plus c, right? It was antiderivative or indefinite integral. So in 5.2, that's the definite integral. So that is denoted as a to b f of x dx. So this a, that's also called the lower limit. Okay, that is called the upper limit of x. What's the difference between this notation and the notation we did in 4.9? Here we don't have any lower limit and upper limit, right? So here we have the lower limit and upper limit, means the variable x runs from a to b. Okay, so that means we have the definite value of x, means x runs from a to b. Okay, that's why this is called the definite integral. So what's the difference between finding the indefinite integral and finding this definite integral? So the geometrical meaning is, let's talk about the geometrical meaning first. So finding a to b f of x dx is, let's first sketch the graph of y equals f of x. So this is our graph. Let's say this is our lower value of a. The reason we call it the lower value means that's the lowest value of x and that's the highest value of x. And here always this is the lower value and b is the upper value. Okay, always you write lower value and this b will be the upper value. So saying that this finding the definite integral a to b f of x dx means you have the graph here y equals f of x and you have the interval a to b, and go ahead and draw the line touching up to the graph from a. So this is the line x equals a. This line is called x equals a. Similarly, so let me write this again, this is x equals a, and similarly go ahead and draw a line here from the point b. So this line, is called x equals b. Okay, so now look, so we have the region here, that region is bounded by this curve y equals f of x, this x-axis, and the line x equals a and x equals b. So this would be the definite integral a to b f of x dx, means that is area of the region bounded by the curve y equals f of x, the x-axis, and the two straight lines x equals a and x equals b. Means finding the definite integral means you are finding the area of this region. Okay, so now if you remember in 5.1, so you had the similar given thing, but you use the Riemann sum to approximate the area, right? You use the upper Riemann sum or the lower Riemann sum and you try to approximate it. But here we are finding the exact area. So that means if you find, instead of doing the Riemann sum, if you find the definite integral a to b f of x dx, means this gives the area of this curve from a to b, or area of the region bounded by the curve of y equals f of x, the x-axis, and the straight line x equals a and x equals b. So here is a very important note. Just go ahead and make a note that the area above the x-axis, if the area is above x-axis, then that takes the plus sign, means our area would be plus. And if the area, the region we are finding the area, if that area is below the x-axis, and then that takes the negative sign. Okay, area below the x-axis are taken with the minus sign. So for example, let's say we have this graph. Let's say this is y equals f of x, and it runs from 0 to 1 is above the x-axis, and 1 to 2 is below the x-axis, and 2 to 3 is again above the x-axis. Let's suppose this part from 0 to 1, let's say this area is a1, okay, and this area is a2. I'm just talking about the area. So this total area is A2 and that total area is A3. Okay, and if someone asks you to find the definite integral 0 to 3 f of x dx, means just go ahead and, so if you are finding the area from 0 to 3, you just go ahead and add these pieces. Okay, you will be adding the pieces from 0 to 1, 1 to 2, and 2 to 3. And then remember, if the area is above the x-axis, it takes the plus sign, and if it is below the x-axis, it takes the minus sign. Means you have this area A1, then minus A2 plus A3. Okay, if this part was also above the x-axis, then we would have plus here. So let's do another example. Take the definite integral from 0 to 2 of x dx. So in this case, our f of x is x. Now let's go ahead and sketch the graph. You can do it in your calculator and just go ahead and copy your graph in your copy, because you need to somehow plot the graph here and see what area you are talking about. So I'll just go ahead and draw the line f of x equals x. It's because our f of x is x, and we are taking the area from 0 to 2. So means I have 0, 1, 2. So then I'll draw the lines from x equals 0 to x equals 2. So x equals 0 is itself here because it is just the point here, and from x equals 2, draw the line up to the graph. Okay, so my graph is here, so I'll draw the line here. Okay, just let's go back here. Here when we had x equals a and x equals b, we had two lines here because a was here and the graph was there, but here the a is itself here, right? So that means we don't need to draw any line here because it touches the point itself, and from here I draw the line up to this graph. So now, finding the definite integral from 0 to 2 means you are finding the area of this region. Okay, so what is the name of this region? What is this? This is a triangle, right? So now go ahead and apply. Sometimes you may get a triangle, rectangle, square, circle. So most of the graphs will be, or most of these regions will be somehow you would have already known. So that just go ahead and apply the formula. Okay, so for example, this is a triangle with base what? This base is 2, and similar this height. Sometimes you will have given the units. If the units were given, you will see what that height will be. If not, if x is 2, my function is f of x equals x, means if x is 2, this y value would be what? Right, this y value will be, if you plug in x equals 2, you get 2, right? So that means this point is 2, 2. That's why this height is also 2. Just remember, it is just a coincidence that this base is 2 and also the height is 2, but it's not necessary that these two base and height will be same. Okay, so most of the time they will be different. So this is, what is the area of the triangle? That is 1/2 times base times the height. Okay, so that means this is 1/2 times base is 2 times the height is 2. So since they are in multiple, you can cancel that 2 and 2 out, so you have just 2. Okay, what about this? If the question was to find the definite integral from -3 to 0 x dx, so again, if the graph is already given, that's better. If not, you need to go ahead and sketch the graph, try it in your calculator and write it down. So again, our f of x here, just I want to start with the simple example. So I took x, means my function f of x is x. Go ahead and plot the graph of this. This is f of x equals x, right? And always look at your lower limit and upper limit. My lower limit is -3 and my upper limit is 0. So that's why I start from -3 up to 0. So here I draw a straight line up to the graph. Okay, and at 0 it is already on the graph. That's why I don't have to draw any line there. So again now, finding this definite integral means we are finding the area of this region. So right? So this now finding the area, I mean, this definite integral means this is 1/2 times base times the height. Okay, again let's go back and remember. So in our previous example here, our graph was above the x-axis, that's why we had a positive sign. But here our graph is our area, this is below the x-axis, that's why we'll give a negative sign here. We'll take a negative sign. Okay, so this is, we take a negative sign here. All right, so this is negative 1/2. We are talking about the base and height of a triangle, that's why even if it goes up to -3, the base, because that's the length we are talking about, right? So this length is 3 times what is the height again. So if you plug in x equals 3 here into the given function, if I plug in x equals 3, the y value is -3. So here this point is in fact -3 comma -3. But again I'm talking about this height of a triangle, that's why that height is 3, right? So it is, just remember, this is 3, that is 3, because these are just the base and height of a triangle. But that -3 came because our graph is below the x-axis. So we have -9/2 is -4.5. Let's do one more example. That is, if you have -3 to 1 x dx. Okay, I did the same example, kind of similar example, but here we had from -3 to 0, and here we had from 0 to 2. But this time I'm going from where to where? -3 to 1. Again, my f of x, just take this f of x is x. So now let's go ahead and draw the graph of our function. This is x-axis, that is y-axis, and our f of x is x. Go ahead and plot the graph of your function. Okay, so this is f of x equals x. So now let's go to the lower limit, means -3. We are starting from -3. Okay, so let's say -3, -2, -1, 0, 1. Okay, means I'm finding the area from this -3 to 1. Okay, so what we do first, we first draw the straight lines from these endpoints to the graph. So here I draw the straight line down to the graph, but here my graph is above the x-axis, so I had to go up here. Okay, so last time either we had from 0 to 2 or -3 to 0, but this time so the area we are finding is this part and that part, right? So now what you can do, instead of directly going from -3 to 1 here, what we do, we break them into two parts. Okay, we first find the area from -3 to 0 and 0 to 1. So just remember here, this is -3 comma -3, and here this is 1 comma 1. So now let's go ahead and find the area of this first part. So this is again, this is below the x-axis, that's why we have negative sign here, right? This is half base times the height. Base is 3 and height is 3, that's why it is -1/2, 3 times 3. And then we add the second part, this one, this is above the x-axis, that's why I will have plus there, plus 1/2. What is the base? Base is 1 times the height is 1. So this is gonna be 9/2, -9/2 plus 1/2, right? So this is -4.5 plus 0.5. So if you do -4.5 plus 0.5, then you should be getting -4. Okay,